All right, thanks folks. Can I just step back for a bit? Does everyone understand the difference between TransGrid and OzGrid and our roles in this neck of the woods? I see a lot of familiar faces, a lot of industry colleagues, but I just want to make sure, because potentially quite a wide range of stakeholders today. TransGrid, the name is a hint, we look after the transmission, which is the major bulk supply paths into the CBD, and OzGrid look after all the sub-transmission 132 kVs and below, that very complex web of cables and feeders within the CBD. Good, it's just important to make sure that's clear. As the slide said, I'm Anthony England. I'm the Group Manager looking after investment strategy and solutions, and that means I wear two hats today. One of those is I'm the guy who sits internally and makes sure that we've really explored to the best of our ability, working with all of you to make sure we've got the most efficient, reliable and safe solution to not just this challenge, but many investment challenges. And the other one is, as part of that, a corollary of that, I've got a job to make sure that we, in a sense, actively help foment and build the demand management non-network industry. It's an emergent industry. A lot of you have been working it for a long time, but we're also equally committed as part of finding the most efficient, reliable solution to helping where we can build that industry to make sure that the ultimate outcome for our customers is what our customers want. All right, I'm going to talk about three things. I'm going to talk about the main driver in a condition sense from TransGrid's point of view, which is the status of cable 41. I'm going to touch on in a bit more detail what Gerard talked about, which is this new proposed reliability standard from IPART, and give you some sense of how impactful that is in the process. And then I'm going to talk about the overall process we're following. So cable 41, so this is our main driver. You can see on the map, it's the lowest one of those red lines, and it runs from Picnic Point in the southwest into our Beaconsfield substation. It's a cable that was built in 1979, so it's actually nearly 40 years old, which is almost the end of its nominal life. So it's a fairly old piece of kit. It's about 20 kilometres long, and as Matt touched on with a lot of the infrastructure we're talking about today, it actually runs under some fairly busy parts of Sydney. So Forest Road, for example, is a fairly congested piece of road transport access. A fair amount of this cable runs directly under the middle of that. Yeah? It's one of those two key cables that does the bulk supply job from TransGrid point of view into the city. Cable 42 is the other one, and it's that line that runs a little bit further in from the Picnic Point again into our Haymarket substation, where our office is actually located just a couple of blocks away. That's cable 42. Cable 41 is the one I wanted to talk about today. So, a bit like what Matt was saying, it's no longer in perfect condition. We have some questions around it. It's not operating to its full capacity. This is not a new story. As I said, it's an old piece of kit, and we've been watching the capacity of this and working on it for quite a few years now. When we put it in, it didn't have a condition monitoring system on it. That technology wasn't really available in the late 70s. When we put cable 42 in, just above it as you can see, there was a condition monitoring system put on cable 42. One of the things it does is measure the temperature around the cable to see how well heat generated by the cable is actually able to be dispersed by the backfill, cement and sand mix, and the surrounding soil. Obviously, if the cable gets too hot, that degrades its capacity. So looking at the cable 42 condition management system, we noticed that we were getting ground temperatures around that cable that were materially higher than the design rating of that cable. And I think it was a 25-degree operating temperature cable. Same rating for cable 41. So we started to recognise, even in the mid to late 2000s, that the backfill and the native soil wasn't actually shedding temperature in a way that it was designed to do. And that started to trigger an alert with us about how we would run that cable. And the loading on both those cables, as the Sydney CBD load grows, has gotten higher and higher and higher. Once we realised that was happening, we started digging into the backfill. So we did some sampling, I think sampled between basically 2004 all the way through to 2009, just to test spot areas all the way along that route to see how the backfill was travelling, whether it was giving us that thermal resistivity that it needed to. As a result of that backfill sampling, we had a couple of international experts come in and give us their view, model the cable's performance and give us their view based on that backfill sampling to see how well, or see how we should rate the cable. That review was concluded in 2010, 2011, and we made a decision at that point to derate the capability of the cable because of that backfill. Since 2011, we've continued to do that. We've actually undergone a full end-to-end backfill sampling of 29 sites. It's completed in 2016, this year, to have a really good systematic look across the whole 20 kilometres about how that cable's travelling. Obviously, at different points in the cable you will have different conditions, and so we wanted to do it comprehensively this time, and the results of that are in, and the condition of the backfill is actually even worse than we expected. We're finding that the thermal dispersion is even less effective than we thought and not sufficient to match its original design rating. So we got the same international expert, Professor Anders, back in to tell us what we should do. We remodelled the cable and we derated it further. I think the original rating of the cable was something like 663 MVA. At the moment, we've derated it down to 426. That is a non-trivial step, obviously. There are some short-term ratings we've put in place to try and maximise the bang for buck we can get, but we've had to wind it back. And we do not imagine that things are going to get better unless something is done. We're now taking the next step. I mentioned it runs down Forest Road, for example. It's hard to dig these things out, but we're actually going to the point now of doing some cable and joint sampling. So we've got some experts in from Japan. They're currently in the process of digging up the roads and pulling sections of that cable out to test and see what kind of effect that's had on the cable, to get a really good idea of the condition of the cable, and the backfill again, to see what the longer term prognosis is, to see whether we can extend that useful life, to see if there's any scope for re-rating the cable either upwards or downwards. So we're currently in the process of that, and we should have the results of that reasonably soon. I'm talking a matter of months rather than a matter of days. It really raises a question of where we go from there. We work to a modified N-2 reliability standard at the moment. I'll talk about the IPART variation on that in a second. Most of you would be aware what that means. It means that we and AusGrid jointly have to plan to be able to supply the entire inner CBD load subject to a removal of one 330 kV cable and one 132 kV AusGrid cable. If we lose any more than that, then we're in a proposition where we may lose some load. So it's designed not to do that. We have two 330 kV cables, and the one that gives us the most concern is cable 41. We've needed to derate that. We're doing further diagnostic work. It's nearly end of life. It's a very complex and costly proposition to replace such a cable. Again, as Matt said, there aren't too many pieces of spare kit lying around for it, and it's a major investment decision to decide to replace that cable to get a better rating. It's also a huge inconvenience to the Sydney going public. So when we're making a decision about what to do with that cable, we have to think very long and very hard. The point is that we're getting to the point of having to make that decision. That's why you're all in the room today. All right, I'll move on. So that's the key driver from TransGrid's point of view. Let me talk about the new reliability standard that IPART have proposed to government. I also want to make it clear, we don't set that reliability standard. We are the service providers. It's a job that's the responsibility of government, and government has asked their independent technical regulator to provide a view about the appropriate price services trade-off that the community expects of us. So, as Gerard mentioned, IPART's been asked to have a look at that and provide their advice to government, and they're reasonably close to doing that at the moment. What they're suggesting is, and it's in two parts, and you can see it there on the line, it's still modified N-2, but what IPART has determined is that there's a small amount of energy which they think it's appropriate not to serve. The theory behind that is that that saves a little bit of money in terms of the investments we make. People are willing to bear a little bit of unserved load in order to make that price services trade-off appropriate. Yeah? So what does 0.6 minutes expected unserved energy per year at average demand mean? Sounds like a scary number. It's actually roughly equivalent to the Uni of New South Wales being out for about an hour a year, or the suburb of Kensington being out for about an hour a year. It's not a small number, but it's also not an earth-shatteringly big number. Now, we have to be clear. This is the first time that someone has proposed a standard that would apply to us where we're working on the basis that we don't serve everybody's energy needs all the time. But it's a relatively small shaving off the top of the energy, of the capacity and capability we're required to plan to serve. So it's a material step in getting that price-services balance right, but it's not an order of magnitude change in the responsibility that we have as service providers to meet the energy needs of the inner CBD area. It's important to understand that context about the new IPART reliability standard, because that's a change that's important, but it doesn't take away from the responsibility we have in terms of investing and planning to meet that inner Sydney CBD need. It's not the key driver of why we're here today. The key drivers are the conditions of the cables and the load forecast. They're actually what we need to remain focused on, because that load growth and capacity reductions actually start to impact us from not this summer probably, but next summer. That's why we're here today, to start talking about solutions. Let me just remind you, Matt showed you a diagram about that amount of unserved energy, the load forecast being the blue line, and our combined capacity being the red line. You can see the red line's declining faster than the blue line's growing. So quite apart from that little expected unserved energy that IPART are proposing in their standard, there's a significant amount of expected unserved energy that we're going to need to invest to be able to address in the future. Now that's the energy dimension. But of course, when you're building network and non-network infrastructure, you need to think about the capacity, the ability of that system or those systems to supply that amount of energy. And this is where the challenge really kicks in. By way of frame-up, if the amount of unserved energy was evenly dispersed across the inner CBD area every day of the year, every hour of the day, then we'd probably need to augment our capacity less. But we can't guarantee that, because events happen, and those events could be very complicated, and they could have a small amount of unserved load for a short time, or potentially quite a large amount of unserved energy for a longer time, or basically everything in between. So when we plan, remember we've got to plan to that modified N-2 standard with a small amount of unserved energy allowance. So that unserved energy on the previous graph is unlikely to be evenly distributed, and that means we have to have a system that has the capacity to manage those shortfalls. And that's what this graph's about. The blue lines are the amount of capacity shortfall we expect in meeting the IPART standard that are likely to happen moving forwards if we do not do something soon. You can see it starts from 2017. It's a megawatts capacity on the left-hand side. And we're getting into some pretty serious numbers pretty quickly. So that gives you an idea of the magnitude of the challenge that we're facing. What are the red lines? The red lines are about a day level of comfort. They're the sorts of operational things, the sorts of emergency short-term ratings we can rely upon between us to actually meet any shortfall in capacity for about 24 hours. After that, we'd run out of options, and you're looking more at the blue lines in terms of potential capacity shortfalls. What are the green lines? Well, if we choose a network option to solve this problem, and we started digging reasonably soon, if we got all the environmental approvals and got through the RIT-T process as fast as we could, we would probably land something on the ground around 21, 22, maybe 22, 23. Yeah? Those green lines give you an indication of the minimum amount of non-network capacity we would need to be able to manage the shortfall and push that network investment out. So it's the deferral value, effectively, yeah? It looks like a lot smaller number than the blue graph. It's the minimum we think is sufficient to defer by 1 year, each year for those 3 years, that network solution. And we're very much looking forward to any non-network options to help us do that if they're economically efficient. But the point of this graph is to remind you that those green lines fall far short of those blue lines. So while we can actually defer sensibly, potentially efficiently, if we find enough non-network solutions, we also have to be aware that until the full bang for buck solution comes in place, whether that's just a network option or a combination of reliable and efficient network and non-network options in combination, we are carrying the difference between the green bar and the blue bars in terms of risk. The room's very silent, and that's good because that suggests to me that you understand the size of the challenge we face. Now, we're here today to explore what those solutions look like. And obviously we need to start relatively soon. One small thing, I should say, you're only seeing a blue line for 2017 and 2018. There's probably a red line in 2017, which is probably about the same height as the blue line. We think we can probably operationally manage that first year. But if the new IPART, well, assuming the new IPART reliability standard comes into play, in fact, regardless of whether it does, we are looking to need some capacity in terms of non-network solutions sometime in the next 18 months. So we can't leave it any later to have this conversation, and we're very keen to work through with you what those options are. All right, last piece of my presentation. So I'll just give you a broad mud map of the process. I said we need to get busy soon, and we've been leading up to this for a while. We've been in conversation about this challenge for a while. Those bottom three lines, all of those bars, I should say, are really to explain what the timing in relation to putting a network solution in the ground would look like. Now, please, for emphasis, I am not saying that we are going with the network solution. That's why we're here today, to explore this. What I'm saying is we don't have a lot of time to come to a landing. We're working very hard with you right now to make sure we understand what the options are. But if we had to go with a network solution, we can't leave it too long to get started. Obviously, there are a couple of key processes before we start to turn soil. The first of those is the process we're undergoing today, which is the RIT-T process. RIT-T, for those who don't know the acronym, Regulatory Investment Test for Transmission. It's really broadly a very sensible process that tries to understand what is a safe, secure, reliable and efficient solution, whether it's network, non-network or a combination of both. And it has some mandatory steps, which are frankly just common sense steps, which are, we put out a PISCA which says, here's the problem we see, the need. Here are our initial thoughts about network solutions, and then over to you to help us understand what the non-network options might look like. You'll all be aware, from having read the PISCA, that submissions in response to that are due on the 13th of January. After that, we go away and we assess what you tell us, and we compare those with the network solutions, and we try and figure out the efficient combinations. We do our economic analysis, and we come back with a draft report, the PADA, Project Assessment Draft Report, sometime around the March or April timeframe. We ask for your views on those solutions. In fact, we'll have identified a preferred solution by that stage. You'll have 6 weeks or thereabouts to actually come back to us with your views on what we put out in the PADA. And we move to a PACA, Project Assessment Conclusions Report, around July or August. By then, we should have a pretty clear idea about what the most sensible way forward would be. At the same time, we'll be starting the paperwork on the environmental planning approvals we'll need if we are to turn soil, if we are to go with a network solution. And shortly after that, we'll be getting into doing some design work. That is simply stuff that it is eminently pragmatic for us to do sooner rather than later. Realistically, we cannot afford to wait and look for an ideal solution right now. We have to start doing some of those things in the office to make sure that we're ready to go as soon as possible. And then as we get sort of into early 2019, we'll be into an implementation phase. Now that could be the network version or the non-network version or the right combination thereof, and be building furiously until we get to around, well, late 21, 22, early 22, 23, so we can have whatever that combination or whatever that preferred solution is in the ground and up and operating. We will be carrying risk until then, and so we're very keen to move do as many pragmatic, sensible things as early as we can, and that's why we're talking to you now. All right, I think that's largely it.